Hi, welcome to the Unit R Day 2 notes. We are working on Example 2, evaluating algebraic expressions. Number 13 starts with parentheses, and then 3x minus 2y, that quantity all squared, and then it says when x equals negative 3 and y equals 2. Whenever you substitute a value in for a variable, you always want to put that in parentheses. That's an always case. So to start this off, I know that I'm going to be using parentheses, so I'm going to change this other parentheses. I'm going to use a bracket instead. This is a bracket, looks like this. So 3, and then instead of x, I'm substituting in negative 3, close parentheses, minus 2 times y is 2, close parentheses, close bracket, and then squared. Notice I'm using that word bracket, that is bracket, and it does mean the same thing as parentheses when you're using it in this sense as a grouping symbol. If I take 3 times negative 3, that gives me negative 9. Minus 2 times 2 is 4. So again, order of operations. And we're doing all of this within the parentheses, even though we've changed them to brackets. Remember, brackets and parentheses are both grouping symbols. Negative 9 minus 4 is negative 13. Now, because of this, if I just type this in my calculator, negative 13 squared, and I don't use the grouping symbol, it's going to give me a different value. It's going to give me a negative value. And the reason behind that is because it just thinks that a 13 is squared. Whenever you have that grouping symbol, you need to make sure that you use your calculator to show, like, hey, I'm actually taking the group of all of negative 13 quantity squared. And that would give me 169. That is evaluated completely. For the next one, number 14, says 4x squared y when x equals negative 3 and y equals 2. So if I, again, plug in or substitute, so I have 4 and then parentheses, negative 3 quantity squared. Notice that that negative 3 is the entirety of negative 3's in the parentheses, and then times negative 2. So following through my order of operations, I'm going to be a good mathematical role model and put equal signs in front of these to show that this is equal to the previous line. You'll see me sometimes do that and sometimes not. Mathematically, if you're working through and solving or simplifying, the equal signs are unnecessary if the reader can understand your work. I realize I need to model good communication here, so I'm going to remember to include those as much as possible. 4 comes down, as is. The negative 3 exponents is resolved first. Negative 3 quantity squared is 9. So I have 4 times 9. I'm going to just put that multiplication symbol as a placeholder. You could do a multiplication dot. You could do parentheses. Do not use an x for multiplication. Obvious reason of, well, we already have x. It's used as the variable. And then the next part times negative 2. So I could have used either a grouping symbol, the multiplication symbol, or parentheses to show that. We multiply from left to right. 4 times 9 is 36. And 36 times negative 2 is negative 72. Oops. 72. There we go. And then number 15. A lot of students freak out with fractions. It's not that bad. So I have 1/2. Now, this x, the way that it writes fractions using math type, that's what I use to write. It puts the x in that location. This is whenever a value is used, it's always in the numerator. So I'm taking 1/2 times 4 over 1. So if I need that denominator, it's helpful to write it this way so that you don't lose track of where exactly that number or that value is. Minus 1/3, again, then times 2. So what is happening here is that we're just multiplying. When you multiply fractions, you just multiply straight across. So this is 4/2 minus 2/3. 4/2 can be simplified. I'm going to do that first. 4/2 is actually 2. So I have 2 minus 2/3. Now if I subtract 2/3 from 2, I am left with 1 1/3, or 4/3. This one, number 16, we now have what I like to refer to as ninja parentheses. They're ninja parentheses because they're hidden. You can't see them. Whenever you have a fraction with operations, you have to do what's in those operations first. So you have to do the entirety of the numerator, the entirety of the denominator, and then simplify the two. So negative 12 times y, in this case negative 2. So I have negative 12 times negative 2, and then plus 5, all over negative 3 times, and then negative 3 from my x value, plus 1. So again, I need to do everything within each set of parentheses first. So I'm going to simplify. Negative 12 times negative 2 is a positive 24, plus 5, over, and then the denominator, negative 3 times negative 3 is positive 9, plus 1. Now I can simplify both parts. Again, ninja parentheses, because I have an operation there. 24 plus 5 is 29. And then 9 plus 1 is 10. And 29 over 10 does not reduce. They don't have any common terms. So there's not a factor that we can factor out of both of those to reduce. So 29 over 10 is sufficient. If I say leave your answer as an improper fraction, this is what I'm looking for. If I'm saying leave your answer as a decimal, then you would put down 2.9. If you divide 29 by 10 in your calculator, you get 2.9. Number 17, evaluate the expression for the integers. Ooh, integers. That's a word that we talked about previously. From negative 3 to 3 inclusive. Inclusive means that you will use both negative 3 and 3. Given x squared minus 2x minus 3. And then I ask what input or inputs give an output of 0. So when you're evaluating the expression for these integers, essentially what you're looking at is you're making, I'm going to use an x chart. So x, and then notice that it just says evaluate the expression. There's no other value of the result, so I'm just going to put the output. We're putting in input of x, so then the result is going to be the output. It says from negative 3 to 3 inclusive, so I'm going to use negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now, you have some space down here that you could work through this. I want to show you in your calculator a nice handy trick. Use the word trick here loosely. Basically, it's using the technology to help in this process. So what I'm going to do is I'm going to set up, I turn my calculator on, and then what I want to do is I want to take what x squared is. So in this case, whenever we plug in or substitute, we always use parentheses, so I'm going to follow that. This first value is negative 3, so I'm going to use that. Negative 3, close parentheses, and then squared. So then the next value then is minus 2, again, open parentheses, again, negative 3, and then minus 3. Now, I'm going to hit enter. It gives me a result. This isn't the result that I wanted because I wanted to know when it gives me 0. I'm going to go ahead and put this on my output anyway. And now what I can do with this value is your calculator, if you have a calculator similar to this, is that you can go to second, and then I want to go to entry. The entry is the enter key. And what happens is the calculator just immediately reprints out the last entry that you've accessed. Now, if I did second entry again, it would give me the one that I've done before this. I don't need that one, I need this one. So you have to be careful, you don't want to do that too many times. How does this help? Well, you can actually use the arrow keys to arrow over and replace the values. So instead of typing this in each time, I can now just do that. Arrow over negative 2, and now I can do that. It gives me a value of 5. Now, some of you may be like, I can just plug this in my head and do it that way. Fine, go for it. Some of you may be like, whoa, this is a huge time-saving thing. Some of you may be like, this is a pretty small formula, I could just type it all out. There's some advantages to this later on, so I'm showing it to you now to hopefully ease the process. Continuing on, now I have negative 1. And that gives me 0. I'm not going to show the rest of these for each of these values. I am going to show you, I'm going to show you one more, because what happens is when you have 0, you notice that you don't need the negative symbol anymore. So the way to get rid of the negative symbol is the delete key, D-E-L, delete key. And you can just delete, and then this overwrites. So delete, and then 0. Similarly, if you needed to put in a negative, maybe you have an order, you would do second insert, and then the negative symbol, and that's how you get that back. So delete gives me negative 3. And then if I put in 1, I get a value of negative 4, and then negative 3, and then 3 should also give me 0. So which values or inputs give an output of 0? So the inputs of -1 and 3 give an output of 0. Join me in the next video as we move on to the last part of these notes. Have a great day.